Hi, look at this diagram. This diagram is one of the part of Young's experiment. It's very popular experiment after Huygens. So in this experiment, uh, in the unique experiment of Thomas Young, he used two pinholes, one with the equal distance between two parallel slits. S to S1 and S to S2 is of equal length. And here you can see the wave fronts. One is responsible for bright fringes and the dotted one will responsible for the dark fringes. As we know, light propagate in Young's and Huygens experiment in a concentric or just like curvature. And as the distance between here you can see the screen which is totally opaque but having two slits, and it is of distance d from the screen, and all the three things are parallel to each other. So what things I am going to explain, that how will you calculate this path difference, and after that we will calculate that the distance of first intensity, that is of bright fringe, and then subsequently dark fringe. So the distances we can calculate, and we will calculate the spacing distance between two consecutive bright fringes. So technical terms, there is very much limitation of time, so you can clear what is constructive, destructive fringes or interferences, and what is wave, how crest, throw, and their consecutive crest give you the lambda distance. These are known to us. So first let us calculate the path difference. So to go into the mathematics, which I have already done for you, let us understand once again this slit S1 and P is a particular wavelength, or it is a distance covered by a light wave, and from here also another narrow slit allows to pass through another light wave. So these have particular distances in suppose meter, centimeter, whatever. So we have to find out the path difference, which is also integral part of our phase difference. So phase difference actually become part of uh, electromagnetic wave equation, your um voltage AC current equation. So it is best you can get idea from here. So you first calculate the path difference S1P minus S2P, but for that you have to first calculate S2P. So if you take this right angle triangle, right angle triangle which is here, you can see it is of S, and this is your M, P, S2, P and M1. These points have been created from this half bisector of S1 and S2 and perpendicular drop on the screen. So you are getting this point M2, P and here S2. It's a right angle triangle, so we can easily apply Pythagoras theorem and we can get this. So here after that you can see that our calculation very simple. D square, that means base square, plus intensity point P and M and their distance, as you can see, P2O plus X, that means X plus D square. So then I have divided both the terms with D by D over D square over D square, and you can easily arrange such, and here you can cut these two numerator denominator, you will get this equation. Just if you take root of this, you will get this term. Now you see, in most of the books there is a term given half, and most of us fail to understand why this is given. So first of all, we can decide that D greater than X plus D, because this X and D is the distance between two slits S1 and S2, and X is the perpendicular drop on screen to intensity point distance. So it is very small in number in context to this green second, that opaque, and this screen parallel, and their distance is D. So now you can easily get that how this term half is there. Half. So it is nothing that if such arrangement we get, so we can compare it with the binomial approximation. This phrase is the result of binomial approximation, and we are applying this, and this is the term. This is the expansion of the term. And now this, out of this, if anybody has confusion at which one is applicable here, I have solved this for you. That suppose if it is the rule and expansion, if we just take this term for each and every given equation, so we can see this only possible if we take this point in A. So it is by this we are deriving the equation with 1 plus half X plus D square over D square. So again, it is very insightful video. I hope it will help many students. So now applying the same process of mathematics, you can easily get the same for S1P, and S1P will give you this. Similarly, from the triangle right hand handed triangle PS1M1. S1P is D plus 1 half into x minus d over d. So what is x minus d? See here, this is the triangle, this small triangle P M2 M this. So in this M2 P and all, D is the screen to opaque pinhole or narrow slit, parallel narrow slit distance, and again this is the S1P is the path of the wave, and this perpendicular is x minus d, because from the bisector O perpendicular dropped M to MO, and the distance between this and this is x. And as we have already seen 2D, D and D distributed, so you can minus from x to get this perpendicular. So now similarly we got it. Now I have given the path difference, not phase difference, it is the path difference, because fringes mostly related with path difference. So already I have derived these two terms, this one and this one. So simply multiply it, and as you are seeing that this D and S2P's D has been cancelled already, and a minus sign is given in between. So this will lead to you this term. So this term I am telling you, this is the x, D and D will help to find out the this green S1P wave length and S2P's distance, not wavelength. Wavelength comprised within that, we'll see. So this term, so how you can see here, I have sort out this, so everything is explained. Just look in very detail, so you are getting this mathematics. Now they will ask you where, at what distance from the this median point of this, the first bright fringe will take place, or this way. So this bright fringe will take at the point intensity point P, first one, at the distance of x. So this depends on two light waves which are passing through a narrow slit S1 and S2, and now we have already calculated the path difference. Now you see this path difference, S2P and S1P. So suppose this wave is of 100 centimeter, because the path is fixed by you within, and then 100 centimeter is 0.01 meter, and then it is 10 to the 7 nanometers. So these two lines may be approximately in that. So this, suppose we calculate with a wavelength of 50 nanometer, you will get the now lambda numbers. It is the lambda numbers. So lambda is such kind of configuration. So if you take the bright or constructive fringes antinodal situation, so you will see this point to this point is lambda. So lambda here covers 2 pi. So whatever the 2 pi, that is lambda, is an integral of n, and n may be 1, 2, 3. That means pi, 2 pi, 3 pi. So we can technically compare lambda n lambda 2x d small d over d capital D for even integer multiples, because pi, 0, 2 pi, 4 pi, it will, as we know, a lambda is a 2 pi, so it will just multiple of that. So here you can get the maxima, first maxima. But most of the students fail. Why it is taken lambda by 2? Suddenly here we have taken n lambda. Now we are confused that why this lambda by 2 is taken and 2n plus 1. See, if you has to prepare dark fringes, so dark fringes always found next to bright fringes. So if this to this distance is 2 pi, so half of that is pi by 2. So pi by 2, if you take, it will be lambda by 2. So that's why, and again it is not odd even number, it should be odd number. So to guarantee even number, odd number, 2n plus 1 is best fit in my consideration, because if you put any out of any number or digits, it will give the odd situations like these consecutively follow every next dark fringes. So we are comparing 2n plus 1. If you put n is equal to 0, you see lambda by 2 is equal to pi by 2, that is dark position. So you calculate this, you will get this minima. Okay, hope you have understood. Again you see, so spacing between n and nth bright fringes, that means just to next one after that. This if I have taken the for bright fringes, if you take the dark fringes, then also it is possible. Just you put the diagram. So n and n plus 1, if you just multiply, you will get this equation. And conclusion you can make, spacing between bright fringes independent of n, because here you see there in this term there is no n, and two consecutive bright fringes is same. Always two consecutive bright fringes have same distance. So up to this, and I will do another video on the intensity and all everything. Thank you.